Hi, this is Sriram from CSC D section 2295NA05L8. This is the presentation of complex matrix inversion. Inversion matrix. Inverse of matrix for a matrix A is denoted by A1. The inverse of a 2 into 2 matrix can be calculated using a simple formula. Further, to find the inverse of a matrix of order 3 or higher, we need to know about the determinant and adjoint of the matrix. The inverse of matrix is another matrix which on multiplying with the given matrix gives the multiplicative identity. The inverse of matrix is used to find the solution of linear equations through the matrix inversion method. Here, let us learn about the formula, methods and terms related to inverse of matrix. What is inverse of matrix? Simple question. The inverse of matrix is another matrix which on multiplication with the given matrix give the multiplicative identity of the given matrix, which is matrix A. For a matrix A, its inverse is A1, A power minus 1, and A into A power minus 1 is equals to A inverse into A, which is equals to I. I represents the identity matrix, where I is the identity matrix. The matrix whose determinant is non-zero and for which the inverse matrix can be calculated is called an invertible matrix. For example, inverse of A1 1 minus 1 0 2 is 1 1 1 1 by 2 0 1 by 2 as A into A inverse 1 minus 1 1 1 by 2 0 1 by 2 is equals to 1 0 0 1, which is equals to 1, and A inverse into A 1 1 by 2 is equals to 1. So these both are equal to I, which is known as identity matrix. Inverse matrix form. In the case of real numbers, the inverse of any real number A was the number A1 such that A times A1 equals 1. We knew that for a real number, the inverse of number was reciprocal of the number as long as number wasn't 0. The inverse of a square matrix A denoted by A1 is the matrix, so that product of A and A1 is identity matrix. The identity matrix, the result will be the same size as matrix A. Inverse of matrix is equals to 1 by that A into adjoint A. 1 by that A into adjoint A. How to find inverse of matrix? To find the inverse of a square matrix A, we use the following formula. A inverse is equals to adjoint A by that A. Adjoint A and that A is not equal to 0 where A is a square matrix, adjoint A is adjoint matrix of A, that A is a determinant of A. Note, for a matrix to have its inverse exist, the given matrix should be a square matrix. The determinant of matrix should not be equal to 0. Rules for row column operations in determinant. The following rules are helpful to perform the row and column operations on determinants. The value of the determinant remains unchanged if the rows and columns are interchanged. The sign of the determinant changes if any two rows or two columns are interchanged. If any two rows or columns of a matrix are equal, then the value of the determinant is 0. If every element of a particular row or column is multiplied by a constant, then the value of the determinant also gets multiplied by the constant. If the elements of a row or column are expressed as a sum of elements, then the determinant can be expressed as a sum of determinants. If the element of a row or column are added or subtracted with the corresponding multiplies of elements of other row or column, then the value of the determinant remains unchanged. Inverse of matrix formula. The inverse of matrix A can be computed using the inverse of matrix formula by dividing the adjoint of a matrix by the determinant of the matrix. The inverse of matrix can be calculated by the following given steps. Step 1. Calculate the minors of all elements of A. the compute of cofactors of all elements and write the cofactor matrix by replacing the elements of A by their corresponding cofactors. Step 3. Find the adjoint of A written as adjoint of A by taking the transpose of cofactor matrix of A. Step 4. Multiply adjoint A by reciprocal of determinant. The following points are helpful to understand more clearly the idea of the inverse of matrix. Inverse of scale matrix. If L6 is unique, if A and B are two invertible matrices of the same order, then AB minus 1 is equal to B minus 1A minus 1. The inverse of matrix. A is X only if the determinant is non-zero, value data is not equal to 0. The determinant of matrix inverse is equal to the reciprocal of the determinant of the original matrix. The determinants of the product of two matrices is equal to the product of the determinant of the two individual matrices. Let AB is equal to det A into det B. For example, complex of original matrix, and this is a complex conjugative and a conjugative transpose. These are not the correct dimensions for multiplication. Thank you. This is about my topic.